All right. Hey, y'all. Okay. I got some quick video notes for you since I can't be here today, and we'll finish this section together, but we're going to start 5.6 with these notes. This final section, we've looked at how to simplify rational expressions, add, subtract, multiply, divide, graph. And this final section is solving rational equations. And the strategy is a lot different from the same type of problem. So I'm putting another problem right next to this. It's the same one. But if I just said, add these together, the strategy for this would be very different than solving this, where you have the equals 0. And I'm going to kind of show you what not to do after I do this first example because of the common mistakes that I've seen before. So to solve a rational equation, I want you guys to think back to how we solved equations with fractions back in Math 2 and Math 3 when you guys learned the fraction buster method. So if I had like x over 3 equals 5, to get rid of that fraction, or the fraction buster is basically whatever is in the denominator so that you eliminate the denominator on this side and then you get your solution. It's a similar line of thought for even more complicated versions of this. When I solve this, I want to get rid of the denominators. It's so much easier to do algebra when we're not dealing with fractions. So same thing, if I want to eliminate this fraction with a denominator of x minus 2, I'm going to multiply every single thing by x minus 2. And if I want to eliminate this one with the denominator of x minus 1, I'm going to multiply everything by x minus 1. In other words, we're multiplying both sides by the common denominator, or the least common denominator. So the common denominator is this product, x minus 2 times x minus 1. So I'm going to multiply this side by that product, x minus 2 times x minus 1. And then I'm going to multiply the right side by x minus 2 by x minus 1, which obviously when I multiply that by 0, it's just going to be 0 still on the right-hand side. But on the left, so this is hard to see, but when I've got x minus 2 times x minus 1, didn't help. Okay, so I'm going to multiply this product by my first fraction. When I multiply that by 5 over x minus 2, this x minus 2 and this x minus 2 are going to cancel each other out, and I'm just left with 5 times x minus 1. So that eliminates the fraction and leaves me with 5 times x minus 1. Then this plus sign comes next. Then I'm going to multiply this product, my common denominator, by my second fraction, 3 over x minus 1. So the x minus 1 here is going to cancel with this x minus 1, and it's going to leave me with 3 times x minus 2. And then on the right-hand side, when I multiply 0 by x minus 2 times x minus 1, I just get 0. So in that single step, multiplying both sides by the common denominator, it eliminates the fractions, and now you've just algebra the rest of the way. I just realized this should be 1. Okay. All right, so now we're just distributing. We've got 5x minus 5 plus 3x minus 6 equals 0. We're going to combine like terms. 8x minus 11 equals 0. So 8x equals 11. So x equals 11 eighths. Before you finalize your solution, just make sure that our solution is not a domain restriction, meaning is this value for a solution even possible based on these restrictions of +1 and +2? So x cannot equal 1 or 2. So 11 eighths is fine. That makes sense. And you could check your work here just by plugging these back into the fractions and make sure that the left-hand side equals 0. So that's it. Now I'm going to show you this post-it. If I just told you to add these and write this as a single fraction with one denominator, what I just tend to see is people forgetting what situations to use which strategies. But if you are solving, meaning you see an equal sign and we want to find out what values of x makes this equation true, your goal is to get rid of the fractions and solve algebraically. If I'm just telling you to add, our goal is not to eliminate the denominator at all. It's to just write this as a single fraction. So in this case, yes, we still need a common denominator, but we're not going to be trying to eliminate the fractions. Instead, since I know my common denominator is the product of these two, I'm just going to do whatever I need to do to each individual fraction to get this to have the common denominator. So now I could have a single fraction, x minus 1 times x minus 2, and then I'm going to distribute in each fraction. And then I would just simplify by combining like terms right here. So I just wanted to emphasize this is the type of problem we've already practiced before, but as soon as you put an equals sign in there and you're solving, it's very different. So I just wanted to reiterate that before we move on. Okay, let's look at another example here. Actually, I think I'm going to jump down to number 3, try and keep this video as short as possible. Okay, so in number 3, we've got 3 fractions on both sides of the equal sign. The first step in a case like this is always going to be factor first, just like so many of our other types of problems. So we want to factor first. So I want to know what multiplies to 11 and adds to 12. That's a pretty simple one with 11 and 1. So I'm going to rewrite my whole problem with that last fraction factored. So x over x plus 1 minus x over x plus 11 equals -1 over x plus 1 times x plus 11. So you'll notice that this is conveniently written so that the right-hand side factors to the product of these other 2 fractions. So the common denominator between all of the fractions is what I want to multiply by. Thankfully, the common denominator between these 2 is the same as this. So again, the first step in this fraction buster idea is just like we did up here. The very first thing we did was multiply everything by the common denominator. And then in the very next step, the fractions were gone. And we're going to do the same thing here. So I'm going to multiply this left-hand side or right-hand side by x plus 1 times x, oops, down here, times x plus 1 times x plus 11. Same thing on this side. Okay, and then as I distribute, so when I distribute this common denominator to the first one, the x plus 1 over x plus 1, those are the 2 that's going to cancel, and I've got x times x plus 11 left. Now this is subtraction, so make sure you're using the correct sign. And then I'm going to distribute this to my second fraction, x over x plus 11. So the x plus 11 is going to cancel, and I'm going to just have x times x plus 1 left. So I've distributed that common denominator to both terms. Now I'm going to do it on the right-hand side, which it's just going to cancel out the entire denominator, and I'm just left with -1. So it's a lot that happens in this first step, but it cleans up all of the fractions right away, and then you're left with a much more basic type of equation that you guys have had a lot of practice solving. So we would distribute, so x squared plus 11x. Now, right here, make sure you're distributing the negative x, so negative x squared, and then minus x equals -1. And now you're just going to get combined like terms on the left. So this is convenient because the x squared minus x squared, so that's gone. And then I have 11x minus 1x, so that's 10x equals -1. X equals -1/10. And then again, just do a quick check. Make sure -1/10 is not a restriction. Our restrictions are -1 and -11. So that works. So that's it. Let's do a few more examples. Okay. So on this next one here, you see that both of our fractions have the same denominator. So that's convenient because my common denominator is just x plus 2. So I'm going to multiply, again, look where the equal sign is. Everything to the right of it gets multiplied by x plus 2, and then everything to the left. So I'm emphasizing this because this x right here, so this x plus 2 is going to be multiplied by this to cancel out that fraction, but it also needs to be distributed to this x as well. So don't forget to distribute it to every single thing on both sides. So when we distribute x plus 2 here, the x plus 2 over x plus 2 cancels, and I'm just left with x. And then when I distribute it to the x, so that this plus is that plus, and then when I distribute it to the x, it's just x times x plus 2. And then on the right-hand side, it just cancels with the denominator, and I'm left with 2 minus x. Again, one step, and then the fractions are gone. The rest of this is pretty simple. All right, so distribute, we get x squared plus 2x equals 2 minus x. And combine like terms. Get everything on one side because we're working with a quadratic, so 3x plus 1x plus 4x. Subtract the 2. All right, so we're left with this quadratic right here. If we wanted to factor it, we'd have to come up with two numbers that multiply to -2 and add to 4. The only numbers that multiply to 2 or -2 are 2 and 1. Those will never add to 4. So this is not factorable. However, we do have the quadratic formula. So x equals opposite b plus or minus the square root of b squared, which is 16, minus 4 times a, which is 1, times c, which is -2, all over 2 times a, which is just 2. So make sure you guys are recalling that quadratic formula because you're definitely going to need it. Okay. 16 minus -8 is 16 plus 8. So square root of 24. Okay, we got to break down the square root of 24. Remember, 24, let me do that over here, can be, if we're thinking of perfect squares, is the same thing as 4 times 6. So I can take the square root of 4. So this is the same as 2 times the square root of 6. So almost done here. We've got -4 plus or minus 2 root 6 over 2. And now I can simplify one last time because -4 and 2 are both divisible by 2. And I'm out of space, so I'm going to go over here. All right, so we end up with -2 plus or minus square root of 6. Okay, so worst case scenario, if it doesn't factor, just be ready to use the quadratic formula in some of these situations. All right, I think I just want to do a couple more with you, and that'll get you set up to do what I want you to do for the rest of class. Okay, so let's take a look at number 5. Number 5, again, I've got multiple fractions, multiple terms on both sides of the equal sign. Again, look at your denominators. The common denominator is going to be the product of n times n plus 1 on the left-hand side, which is exactly the denominator on the right-hand side. So that's convenient because n times n plus 1 is just the common denominator. Okay, another just warning here is this 1 right here. Terms like that don't have any variables are often forgotten. So remember that we are distributing n, the common denominator, n times n plus 1 to that as well. And then on this side, n times n plus 1. Okay, so we'll start on the left and then go over here to the right. So n times n plus 1. When I multiply that by my first fraction, the n in the numerator and denominator cancel, and I'm just left with 1 times n plus 1. So I'm just left with n plus 1. And then this plus sign is next. And then I'm distributing n times n plus 1 times 1 over n plus 1. So my n plus 1s are going to cancel. I'm just left with 1 times n. So that's it on the left-hand side. On the right-hand side, so I distribute my common denominator times 1. So that's just n times n plus 1. And then when I multiply that by the second one, so this minus is coming next, so minus And then it just cancels perfectly with the denominator, and I just have -1 left. So again, it's a lot that happens, but it simplifies really nicely. So at this point, you can combine like terms. So I have 2n plus 1 equals n squared plus 1n minus 1. Since we've got this quadratic on the right, we are just going to add or subtract 2n and subtract 1. And we'll get our quadratic of n squared minus n minus 2 equals 0. And then we can factor, hopefully. So something that multiplies to -2 adds to -1, -2 times 1, and -2 plus 1. So we've got n minus 2, n plus 1. So we've got our two solutions of +2 and -1. Before you circle your answer, again, look back at our restriction. So this is an example of one where we've got two restrictions, n can't equal 0 or -1. So if we know n can't equal -1 because it's a restriction, then this solution of -1 is not usable. So the only solution is 2. Even though we got -1 from solving, that's a restriction here, so we can't. Okay, one more. So I want to jump down to number 8. And then I'll give you guys the rest of the time to work on problems in class. All right, so for this one, the only fraction is this right here, and we've got 2x minus 7 as the denominator. It's the same strategy though. So even though there's only one fraction, I want to eliminate that denominator so that the rest of the problem doesn't contain any fractions. So to do that, I kind of think I'm going to multiply both sides by 2x minus 7. So on the right, I'm just going to distribute those two together. But on the left, you can think of it as multiplying 2x minus 7 to 3x and then to 5. Or you can think of it as multiplying it to this as a group 3x plus 5. And that kind of does a little bit more in one step. So we're multiplying this whole side by 2x minus 7. So when I multiply that through to my first, again, I could have just done it times 3x and then times +5, or I can just do it all at once. So 2x minus 7 times 3x plus 5 will distribute that in the next step. Multiply it by this fraction, so that's just going to eliminate the denominator. So my plus sign here comes next, and then I'm just left with 8 because that's going to eliminate the denominator. And then on the right-hand side, I can go ahead and just distribute this in this step. So 6x times 2x, 12x squared, 6x times -7, -42x, plus 2x, minus 7. And then I'm going to distribute on the left-hand side as well. 2x times 3x, 6x squared, 5, -7 times 3x, -5. Don't forget this plus 8. So we've got a lot of terms, but we can combine in a second. Okay. Where did this? That's 40x. Okay. Hopefully I'm not making too many mistakes right now. Alrighty. Now we just need to combine like terms over here. 6x squared, 10x minus 21x, that's 11x, -35 plus 8. Let's see, that's negative. Okay. Now we can just, since we've got two quadratics, put everything on one side, factor, or use the quadratic formula. So I'm going to subtract 6x. I'm going to add 11x. 27. So we end up with 1 quadratic on the right-hand side. And then this is going to factor. So, oops, sorry. 1 second. Okay. Okay, so this is we're gonna see if this factors. That would be great if it did. So again, this leading term is not 1, so we're gonna need to multiply 6 times 20. So we're looking at diamond with 120 in the top, and then negative 29 down here. So I would expect this to take some time. Hopefully you guys would grab your calculators and start figuring out 2 numbers that multiply to 120. I would start with things like 30 times 4, since 3 times 4 is 12, but that won't add to 29. 60 times 2, more and more things like that. I'm just gonna spoil it for you. What is it? It's negative. So 24 and 5 multiply to 120. So negative 24 and negative 5 multiply to positive 120, add to negative 129. Those are not how this factors. That's just going to help me fill in my area model for this. And then we'll get our solution for those factors. So we've got 6x squared, 20, negative 24x, negative 5x. So this is going to be 6x and 1x. All right, so we've got our box figured out, and now we've got our 2 factors, x minus 4 and 6x minus 5. Okay, 2 solutions. We've got x equals positive 4. Just make sure that's not a restriction. The only restriction we would have from up here is when x equals positive 7 over 2, 7 halves, so 3 1/2. So this solution down here, if we set 6x minus 5 equals 0, add 5, divide by 6, we get 5, 6. Neither of those are restrictions. So we've got our 2 answers there. Okay. Obviously, there's more examples here, but it is the same process over and over. So I think this is good. I want you guys to do problems 1 through 4 on your homework in class for the rest of it. And then you can walk out of here with no homework, since that's all I want you to do are problems 1 through 4 that are very similar to these. Okie doke. Thanks, guys. See you soon.